So now we're going to do the same thing with a 3x3 systems of equations. Wait for it. And we learned two ways of finding the determinant. I really like rewriting and doing 3 arrows this way, adding those up, 3 diagonals this way, adding those up and making this one negative. So it'll be the purple one, subtract the red one to find your determinant. So we're going to find the determinant of this matrix. Again, if I rewrote one, well, I'll do it in black. 1, 2, -2 and 5, 3 and 1. This first blue arrow, 1 times 5 times 2, that gives me the 10. Second blue arrow, 2 times 1 times 3, that gives me 6. And this third diagonal, 4 times -2 times 1 gives me the -8. Adding those up gets me 8. My red arrows, 4 times 5 times 3, that would give me the 60. 1 times 1 times 1, that would give me the 1. And 2 times -2 times 2, give me the -8. This is not sure what happened. There we go, let's erase that part. So now I can do the 8 minus the 53. And I get my determinant that way. Without a calculator, this is my preferred method. But if we want to do it with the formula, okay, and now I'm going to erase my arrows so I can talk about the formula. This one in the green box takes this number, ignores these, and multiplies by the determinant of what is left. Next, the one in the purple box. That takes the second number, ignores its row and column, and does the determinant of the numbers that are left, and the second one always has a negative sign. And follow this pattern. On the third one, take the last number, which is a 4, multiply by the determinant of what is left. This is going to be 10 minus 1, which is 9. This one's going to be -4 minus 3, which is -7. This one's going to be -2 minus 15, -17. Put those together, and we get the same answer that we did above. So you can choose if it's a 3x3 on a non-calculator part of your test. That's asking you to find the determinant. You can choose whichever method. I'm not going to say, do it using the formula. And you're like, I just remembered the other way. Now, the process of finding the inverse of a 3x3 matrix is kind of crazy. And I'm going to see if I can show you. Yeah. So we're going to use our calculator because here I've got a website And you have to learn about the adjoint of a matrix, which we haven't learned yet. Does that look like fun? This is its cofactor matrix. We have to learn that. And then you use your cofactor, you find your determinant. Step 1, step 2, step 3. Yeah, it is not. We're going to close that. It is actually a fairly long process. When we get later on in the unit, I'm going to show you a process that you could, if you wanted to, find the inverse of a 3x3 matrix using some of the techniques we learn later in this unit. But right now, we're going to mainly use our calculator. But this first question is a non-calculator question. It says, given this matrix P, determine a value of X for which P inverse does not exist. So the inverse of a matrix will not exist if the determinant is 0. So I rewrote column 1 and column 2 there. I did my blue arrows. I did my red arrows. And I could set my determinant equal to 0. Added up my blue arrows, which was 4x minus 2. Subtracted my red arrows, which was x minus 16. I can solve for x here. And if x is negative 14 over 3, then the determinant would equal 0. And if the determinant equals 0, the inverse doesn't exist. Or you could use the formula. This is using the formula. It would give you the same answer. So this side, the blue and the red side, is using the arrows. The black side here, this is using the formula. Either way, that's the value of x that will not give you a determinant. Okay, so you're going to take out your calculators. I'm going to open mine up here as well. And I'm going to get you to put A and B into your calculators. Oops. And I'm going to put them in as well, but off to the side here. Well, actually, you don't have to write anything down. I can do it right here. Oh, then I can't see. I'll do it off to the side. All right. I'm going to just bring this in here. Oh, then you can see it there. So matrix A, 1, 2, 0, negative 2, 0, 1, 1, 3, 4. That's good. And now I'm going to go second matrix and edit B. And B is also going to be a 3 by 3. 1, 1, negative 5. Oh. I gotta do it over here. Negative 4. It is a normal 5. Thank you. I will All right. I'll bring it over here. Do I got B incorrect? 115. Now I've fixed that. -4, -5, -2, -7, 4, and 7. So we're going to use our calculator. GDC stands for Graphic Display Calculator. Much shorter than writing calculator. And we're going to use our calculator to find A inverse. So how do we do that? Well, we open up our calculator. We go to our main screen, clear everything out here, and I can go second matrix and select matrix A. And then above the x squared button right here, x inverse button. And it gives us lots of decimals. So it's going to make sense to hit our math button and change these back to fractions. If you wanted to, like, can you see that I have a 1/15 kind of in common in here? If I wanted to factor that 1/15 out, I could just actually go 15 times A. I forgot the 5. If I do 15 times A, that didn't work. Oh, I wanted to do 15 times A inverse. 15 times matrix A inverse. Then it should give me -3, 8, -8, 2. Do you see that? Compared to that other one that I had up here before, it has just taken the 15 and factored that out. Anyways, there is our A inverse matrix. And now we want to find a matrix P using our calculator, because this would be very hard to do otherwise. Find a matrix P so that A times P equals B. There are some things that we can figure out. For example, if this is true, and B is a 3×3, and A is a 3×3, in order to multiply by P, matrix multiplication, they have to be compatible, right? Which means that the middle numbers have to be the same. So I know that P has to be a 3×something. And I know that P is going to be a 3×3 as well, because these outside numbers give you the dimensions of your answer. So I know that P is going to be a 3×3. But now I'm going to use my calculator to figure out what P is. Anytime you want to, like if this was algebra, you would say I could get P by itself by dividing both sides by A. But there is no dividing in matrices. Instead, matrices has inverses. Inverses get rid of things, or make it the identity matrix, which means it's multiplying by 1 and would go away. So if I want to get rid of the A, I have to multiply by A inverse. Careful, because if you multiply by A inverse on the front on this side, you have to multiply by A inverse on the front on this side. If you multiply A inverse on the back on the other side, you will get an answer that means absolutely nothing. It's possible to get that answer, but it could be completely and utterly wrong. So I multiply by A inverse in the front on both sides. That would cancel out that A. And then in my calculator, I now have the following, that P is equal to A inverse times B. So I pull out my calculator and I write this in. So can go to my matrix, matrix A, make it an inverse, and then second matrix B. Calculator's smart. If those two matrices are beside each other, it knows that you're multiplying. And so A inverse times B is this. And I'm going to take this answer and I'm going to store it as, do we have second matrix? Do they have all the way up to P? No. They have that. Oh, they go. Wow. They give me the arrow, making me think I'm going to have the entire alphabet at my fingertips. And they give you one more. J. Which of these letters? I'm going to go with B because it rhymes with P. Seems logical. So I'm going to store that answer as D. The reason I'm going to do that is I'm going to do a quick check. Okay? We did get this answer for P. And if it's right, then my original second matrix A times second matrix P, which is being substituted by the stunt double D, this should equal, when I push enter, our matrix B originally. 115, negative 4, negative 5, negative 2, negative 7, 4, 7. Yes. Or you could check it by hand by taking row 1, multiply by column 1, add up the pieces. Then you have to do row 1 by column 2, row 1 by column 3, then row 2 by column 1, row 2 by column 2, row 2 by column 3. Multiply all those out, add up all those pieces. Multiplying a 3 by 3 by a 3 by 3 by hand is a lot of calculations. So we're going to set up this with matrices and use our calculator. And you may prefer this. Remember when we solved this at the beginning of this unit with systems of equations? You have 3 equations, 1, 2, and 3, with 3 unknowns. You would have had to decide which one you're going to cancel out. Should I get rid of all the x's and get 2 new equations with just y and z? And then you could use elimination again and finally find z, then solve backwards and find y, then solve backwards and find x. But what we're going to do is we're going to set up a matrix equation. Our coefficients matrix is our matrix A. Again, what's really important is that column 1 is x's, column 2 is y's, column 3 is z's. If we put this into our calculator as A, and this into our calculator as B, can you set it up so you can solve for x with your calculator? I will put up the answer in a little bit. So then to get x by itself, we multiply by A inverse in the front. You have the A and B typed into your calculator. So you type in A inverse B into your calculator. Did you get 4, 1, negative 1? That's pretty slick compared to setting up your systems of equations and solving all three. I would say for 2x2 matrices, systems of equations is just as fast, if not faster, than the setup and plugging everything into your calculator. But for this is actually quite nice for saving time. So I want you to try this one, the last one, on your own as well. Oh yeah, let's see how you did. So we set up our matrices and we notice the first equation doesn't have a z, so we can put a 0 in for that. Hopefully you figured that out. Double check that your columns all match up. Sometimes you have to rearrange your equations a little bit to make sure that the first column's all x's, second one's all y's. Multiply by the A inverse, and you get 5, 4, -1.